gentle and of course very modern apes, I've gotten a little bit sick of young Earth creationists trying to pretend that they can make Neanderthals work with a 6,000-year-old Earth. They've been at this one for a long time now, both at the professional and amateur level, and so I think it's high time that I clobbered it.
I am a 100% thoroughbred, tried and true hater. I love to hate. It is the best. It gets me through the day. I love it.
Now, as we all know, Young Earth Creationism, which is the idea that the Earth was created more or less in its present state by God, usually the Abrahamic God, roughly 6,000 to 10,000 years ago, and that the entirety of the geologic column is the result of Noah's flood. Well, we know that that entire idea is brutally false, and this is demonstrated by dozens upon dozens upon dozens of fields within science generally. From the radioactive decay law, the speed of light, and the nature of the geologic column to the statistics that surround common ancestry, the fossil record of course, and our relationship to the rest of the apes, the primates, and the tree of life as a whole. All of these lines, and indeed many more, don't just make young Earth creationism extremely unlikely, but they actually preclude it entirely as an idea. Creationists, though, have not gotten the memo, and so as a result, they tried to take everything we know about the natural world, the entire data set, and sort of force fit it into the idea of young Earth creationism. And that includes some of our hominin relatives, like Neanderthals. Homo neanderthalensis, or Neanderthals as they are colloquially known, are a well-characterized hominin that lived from 800,000 years ago to just 40,000 years ago. They shared the world with our own species, Homo sapiens, as well as many other hominins such as denisovans, Homo floresiensis, Homo naledi, Homo luzonensis, and perhaps even more. Both our species share a common ancestor in the form of a group of hominins that we generally call Homo heidelbergensis, but while we, Homo sapiens, evolved in Africa, Neanderthals evolved in Eurasia.
No. It was no 15 minutes ago, and it's no now. Like, every time.
So to sum things up really simply so far, you can think of Neanderthals as a species being a sister group to Homo sapiens. Sort of like you and your sibling share a common ancestor in the form of your mom and dad, Homo sapiens and Homo neanderthalensis share a common ancestor, a parent species, in the form of this group, Homo heidelbergensis. Editing Gibbon here, I'm just going to clarify something real quick. I think Homo heidelbergensis, as I said in the little note earlier, is probably a mixture of these sort of pre-Neanderthalensis, pre-Homo sapiens morphotypes, and what that would mean is that the last common ancestor between Neanderthals and Homo sapiens is Homo erectus. It doesn't functionally matter for our arguments today, right? Those specimens still exist regardless of what we want to call them, but it does mean that it changes our time frame for Homo neanderthalensis. If we want to do sensu stricto, which is going to be how I do it for the remainder of the video, Homo neanderthalensis starts 400,000 years ago and still goes extinct 40,000 years ago. I probably should have just re-edited that first part, but I'm never going to not present you with the nuance of hominin evolution and my opinion on it.
That makes me a bitch. Okay.
That's important because what that means is that we did not descend from Neanderthals any more than you descend from your sibling. It also means that they did not descend from us, which is a point that we're going to touch on a little bit later. The mitochondrial common ancestor between humans and Neanderthals lived between 360 and 468,000 years ago, and the Y chromosomal ancestor lived between 447 and 806,000 years ago. What that means is that the last common male ancestor between humans and Neanderthals lived more distantly in the past than the last common female ancestor of us both. Moving forward in this video, I'm going to say human and mean Homo sapiens, and I'm going to say Neanderthal and mean Homo neanderthalensis. I am aware that Homo means human, and technically that means anything in genus Homo is human, but this is just for the sake of brevity, so I don't have to spit the nomenclature at you every 6 seconds. When Neanderthals were first discovered in the 1800s, it was pretty common to see people consider them as these brutish animalistic cavemen that were closer to other apes than they were to humans. They were dumb, they were slow, they weren't very clever or cunning. This actually led some to even propose that the nomenclature for this hominin should be Homo stupidus. Extensive work since then on their morphology, their behavior, and of course their genetics has revealed that Neanderthals are a very close relative of humans and were capable of pretty much everything that archaic Homo sapiens was when they lived side by side. I really don't think that these folks, these early paleoanthropologists, deserve nearly as much flack for that mistake as we tend to give them these days. Homo neanderthalensis was the first hominin actually discovered, so all we had to compare was modern chimpanzees, the panins, Neanderthals, and modern Homo sapiens. And at the time, it seemed that Neanderthals fit quite neatly in between the two. They had a more prognathic face, a strong brow ridge, a low sloping brain case. With only morphology and few specimens, I think it's fair to fit Neanderthals in between chimps and humans. Now that we have many, many more hominin species, this is no longer the case, and it's clear Neanderthals are closer to us than they are to anything else. All that to say, I don't think that it was as big of a flub up as people tend to assert today, pointing and laughing at these older scientists as if they had no clue what they were talking about. Many of these guys were trained anatomists and knew anatomy better than almost anyone alive today. That was their specialty. And what they saw was a morphology in Homo neanderthalensis that in many ways appeared more basal as compared to modern humans. More specimens has allowed us to revise our morphologic comparisons, and then additionally we have genetics now so we can see for sure where they land as compared to Homo sapiens and archaic Homo sapiens and the other apes and other hominins that we have DNA from. And we also have many more sites that preserve behavioral aspects of Homo neanderthalensis. Neanderthals mastered the Mousterian tool industry, utilized fire and hearths, and hunted big game. They could create knots using woven rope, treat injuries in tribe mates, and cook their food. They buried their dead, potentially decorating them in flowers and red ochre, and perhaps even created art in the form of cave paintings or instruments. Seeing their unique morphology that had its own autapomorphies combined with all these very advanced human-like behaviors, we started to sort of lean towards the idea that maybe they were a sister species, but genetics is what really sealed the deal. Over 24 individual Neanderthal genomes have been sequenced, and from these, we know that Neanderthals are 99.7% similar to humans in their protein coding regions. For comparison, the two most distant humans on the planet, the two most dissimilar genomically individuals, will be 99.9% similar to one another, which means that Neanderthals fall outside of modern human variation. For comparison, humans are 98.8% similar in the protein coding regions to chimpanzees, for sure. And Neanderthals are about that similar to chimpanzees as well, for sure. This confirmed for us that Neanderthals are more similar to humans than they are to chimpanzees. They are a lot more close to Homo sapiens than they are to the earliest hominin in the form of something like Sahelanthropus chidensis. But things get more interesting. We actually know that our species and theirs interbred thanks to Neanderthal DNA's presence in the modern human genome. The amount depends on where you're from. Neanderthals were a Eurasian species, so those with Northern European ancestry have the highest number, being about 4 to 5% Neanderthal when their genomes are sequenced. This is likely due to the frequent contact that early Homo sapiens moving into Eurasia had with the Neanderthals, and contrasts greatly with the very low amount of Neanderthal DNA present in those with African ancestry. This disparity matches our expectations if Homo sapiens first evolved in Africa before migrating out into the rest of the world and interbreeding with the hominins there. Put a pin in that one, it's going to be devastating for young Earth creationists. Now, from their genomes, we also know that particularly late in the species lifespan of Homo neanderthalensis, these guys were ridiculously inbred. And in fact, there were never really that many Neanderthals on the face of the earth at any given time. It's thought that their population size never exceeded 10,000 individuals. Europe during the Pleistocene was not a very friendly place, and neither was Asia. So what probably was going on is that as Neanderthals evolved there, they could really only form and maintain relatively small group sizes that migrated along with their game and with the seasons. What that meant is that as Neanderthals began to go extinct, these already spread out small tribes became more and more isolated from one another and were forced to inbreed in order to survive. Homo sapiens comparatively formed and lived in much larger groups for reasons that we don't entirely understand yet, and so probably didn't face this problem. Okay, so all of that being said, why are Neanderthals so problematic for young Earth creationism? Like, I feel like by hearing all of this, you intuitively can see that there are issues, but what specifically are the issues? It's a long story.
Young Earth creationism requires a spontaneous creation event some 6,000 years ago, as well as a global flood event some 4,400 years ago that is responsible for all layers of the geologic column from the Cambrian to the Cretaceous, as well as their fossils, every impact event or mass extinction signature within said layers, the current positioning of the continents, the state of decay of all radioactive elements, and finally, the various levels of diversity for all extant life.
Generally, this means that young Earth creationists are allergic to human evolution and spurn it in all its forms, with a few exceptions. They really like Neanderthals.
So you must go.
And they've come around to them over the years because they've found a way to sort of force fit them into young Earth creationism. Now, after hearing all that I've said, you might be thinking, how on earth could they do that? Allow me to explain. Young Earth creationists suppose that Neanderthals are fully human. And I know what you're thinking when you hear that. Of course they're fully human. They're a member of Homo. They're Homo Neanderthalensis. Homo means human, so they're human in that sense. But there's a reason why I defined my terms the way that I did earlier. Creationists will not define what a human is. They do not have criteria to define the humankind. And so absent a definition, we are left to assume that what they mean when they say human is Homo sapiens. I think this holds when you read their articles and listen to them talk about it in videos.
Regarding Neanderthals, they certainly do fit with a biblical perspective of world history. So they would have been human beings, post-flood people groups that quickly spread out after the time of the Tower of Babel. And evolutionary reconstructions of Neanderthals are catching up to the biblical point of view. That in museums today, they seem to be depicted as more and more human. The more we learn about them, the more that becomes clear.
They effectively think that anything in the humankind, which again is separate from apes for reasons that they will not actually define either morphologically, genetically, behaviorally, whatever, but all of the hominins that they suppose are within the humankind should be Homo sapiens, whatever their species is. So Neanderthal should be Homo sapiens neanderthalensis. Before the Neanderthal genome was really sequenced, there was a group of people that thought that Neanderthals should be Homo sapiens neanderthalensis, but that idea has really fallen out of vogue due to the fact that they are in fact outside of modern human variation and also have their own morphologic autapomorphies. But things get a little bit weirder, because generally creationists suppose that anything that is like roughly humanish, usually this extends to Homo erectus, sometimes earlier hominins, that all of those are in the humankind, and thus all of them, I suppose, are also Homo sapiens, so like it would be Homo sapiens erectus. So there are innumerable problems with that as an idea. First and foremost being there is an insane amount of morphologic and genetic variation just between humans and Neanderthals, let alone including Homo heidelbergensis, Homo erectus, Homo naledi, Homo floresiensis, and on and on and on. This is not tenable. This would be like saying that all of Canidae, dogs, wolves, dingoes, foxes, all of those are actually just one species. Canis lupus whatever their actual species name is. It is absurd, and it's completely inconsistent with how we classify all other organisms. It's special pleading. But also, those hominins, morphologically and genetically, form a phylogeny, like an ancestor-descendant series of relationships. So creationists believe that God created Adam and Eve in the Garden of Eden. How do we deal with these hominins under that context? And I have seen 2 shots made by creationists. I suppose I should specify by Young Earth Creationists. The first Young Earth Creationist argument, and by far and away the more popular of the 2, is the idea that God creates Adam and Eve in the Garden of Eden. They are Homo sapiens, and all of the other hominins that we have are the result of genetic degradation after Adam and Eve sin and get kicked out of the garden. Usually, genetic entropy, another debunked creationist idea, is pointed to explain how this degradation would happen, and so for that reason, I'm going to call that the degradation model. The second model is more interesting, it's less popular, but it actually holds that Adam and Eve are not Homo sapiens, at least not in the sense that we understand it conventionally. They actually propose that Adam and Eve may have been like Homo erectus or Homo heidelbergensis, and after they get kicked out of the garden for non-genetic entropy reasons, evolution just kind of happens to these guys. They continue to change and evolve, and then you end up with all of the forms that conventionally would result after Homo erectus. Basically, it's just normal human evolution on super, hyper, maximum overdrive happening ridiculously quickly from the point of Homo erectus onward. It's truncated, but it's human evolution nonetheless. And so for that reason, I'm going to call that the truncation model. But there's an additional little snafu here because all of our hominin fossils are in the Cenozoic, and in fact, they're Miocene forward. And so what that means is that all of the hominins are going to be fossilized during the time period after Noah's flood, since almost no young Earth creationists propose that the Miocene onward is flood rock, although there are some that do. I say this because while the degradation model and the truncation model both make specific predictions that we'll touch on later, and they differ in many ways, this is one prediction that is shared by both. In both the degradation model and the truncation model, Neanderthals as a species must descend from Noah and his sons. This has obviously enormous implications genetically, and given we have the Neanderthal genome and the human genome, we can actually investigate this, because both of them thus propose that you should be able to get all of human and all of Neanderthal genetic diversity in just 4,400 years, and that last shared common ancestor between those two species can be traced back to a time period less than that. Let's briefly compare the degradation model and the truncation model with regard to what they predict and what shared predictions they have before we move forward on annihilating them both systematically. In both models, Neanderthals and Homo sapiens descend from Noah. You'll see this later, but it doesn't really matter that we specify Noah over Adam here, because the difference between 4,400 years ago and 6,000 years ago, working with the genetics that we'll be working with, just isn't a game changer for them. Both models also argue that Neanderthals and humans are the same species. Remember, technically they argue more or less that all the hominins are the same species, but for our purposes today, we're only concerned about humans and Neanderthals. And both models propose that the last common ancestor of both of them came from the Middle East as opposed to Africa. That one's a biggie, but there is a difference in the two models, right? So under the degradation model, humans originate in the Middle East, and then also Noah lands in the Middle East, and then Neanderthals nest underneath Homo sapiens. But in the truncated model, Adam and Eve are some different type of hominin species, and Noah is probably also a different type of hominin species that is ancestral to Neanderthals and Homo sapiens. So under that model, Neanderthals wouldn't necessarily nest inside Homo sapiens unless those creationists suppose Noah was Homo sapiens, and I don't think they do. So Neanderthals wouldn't have to nest within Homo sapiens, but that common ancestor would still have to come from the Middle East. In the degradation model, Adam, Eve, and Noah are Homo sapiens, the species, and all other members of genus Homo are degraded versions of Homo sapiens via genetic entropy. And so Neanderthals should nest within Homo sapiens genetically. On the other hand, in the truncation model, Adam, Eve, and Noah are more basal hominins like Homo erectus or Homo heidelbergensis. All other hominins are evolved or degraded versions of the Noah hominin, and Neanderthals do not necessarily nest inside Homo sapiens. Oh my goodness, and I should add, both models have a maximum of 6,000 years and a minimum of 4,400 years, so we're just going to assume that they have 6,000. In both models, Noah's Ark lands on Mount Ararat, and Noah's sons and their wives spread across the earth to different locations and incestuously repopulate it. In the degradation model, Noah himself is Homo sapiens, and in the truncation model, he is something else, probably Homo heidelbergensis or something similar, and in both models, there is a serious concentration of humans still in the Middle East that eventually will build the Tower of Babel. The degradation model is the more popular model, and when I say more popular, I mean I'm pretty sure it's held by all three of the major Young Earth Creationist organizations, CMI, ICR, and AIG, and this is, I think, for pretty obvious reasons. If Neanderthals are a different species from Homo sapiens, then that means even if they're very, very similar, humans can still evolve, and I don't think any of the creationists of these popular orgs want to admit that. No, instead, Neanderthals just descend from humans and are also just humans themselves, albeit very degraded ones. Specifically, so the degradation model goes, they are a population that split off from Babel, was one of the first ones to head north into the harsh environment of Europe, where they were simultaneously hypermutating and also inbreeding excessively, which explains why they look like that. A little bit, apish, and why their genomes are so different.
Okay.
The truncation model plays out almost exactly the same, except instead of Neanderthals just being a descendant of Homo sapiens and also Homo sapiens themselves, Neanderthals and Homo sapiens are both descendants of some other hominin, as I've said like a dozen times by now, which means that they allows for some degree of evolution within genus Homo, and then I think they also still suggest that genetic entropy is responsible for some of the more basal-looking states of things like Homo naledi and Homo floresiensis and Neanderthals. There are other versions of the truncation model coming out of like the New Creation blog and things like that that are even more accepting of conventional science than the one we're going to be addressing today. And I love that, that's great, I support that notion moving towards conventional science, but it's plagued by many of the same problems that the truncation model that I'm presenting to you now is plagued by, so we're just going to grapple with that version of it. The very first step where we are going to start here is going to be debunking the popular notion by Young Earth Creationists that Neanderthals are fully human, that they are in effect Homo sapiens and should be considered Homo sapiens neanderthalensis.
I don't have a headache. I'm just preparing.
Unequivocally, Neanderthals, Homo neanderthalensis, are a sister species to Homo sapiens. They are a distinct species genetically, morphologically, and arguably behaviorally that do not descend from us. We share a common ancestor. So first and foremost, I think we should ask the question, what, if anything, is a species? And the answer to this is a very long and complicated one. I made a whole video on it. A species is one of the most specific categories an organism can fall into. While other clades, such as families, contain many different organisms, a species will commonly contain only one. For instance, Felidae is a family that contains lions, leopards, tigers, servals, and domestic cats, among many others. But Felis catus is a species and contains only the domestic cat. Think of each taxonomic rank as a further specification of an organism's categorical place. Because of this system, it is easy to place organisms into larger ranks like family or order, and much more difficult to distinguish whether two similar organisms should be in the same species or not. If they belong to the same species, they sometimes receive subspecies designations. In the case of our humans and Neanderthals, the latter would become Homo sapiens neanderthalensis. So how do we actually decide whether or not organisms belong to the same species or not? The answer is that it is complicated and it depends on who you ask and the types of taxa that you're looking at. In grade school, we teach what's called the biological species concept, which more or less states that if two organisms can interbreed and create viable offspring, as in offspring that can then itself reproduce, viable and fertile, I should say, offspring, then they are the same species. This is the concept that creationists glom onto with Neanderthals and Homo sapiens, since the two could, in fact, produce fertile, viable offspring. Unfortunately, in practice, this definition kind of rarely works because biology is very messy, and this is something that, I kid you not, has been recognized since Charles Darwin published Origin, and I know because I just read that book cover to cover and updated people on Twitter while I was doing it. He complains for entire chapters about how species is virtually an unreal category. For instance, European wildcats, African wildcats, and domestic cats can all interbreed, but they each have their own species: Felis sylvestris, Felis libica, and Felis catus. Grizzly bears and polar bears can also interbreed, as can Chinese and American paddlefish. And Russian sturgeon and American paddlefish, while I'm at it. And each of these pairings can produce viable, fertile, hybrid offspring, but no one would propose they are indeed different species. In practice, as noted by biological anthropologist Ian Tattersall, species are morphologically distinct organisms who, quote, maintain their historical identity over sustained periods of time, regardless of any incidental gene inflow or outflow at the edges, unquote. Interbreeding can occur then, although it should not be the norm as dictated by the recognition of potential mates and by the organism itself. I think it goes without saying, but this species concept, as outlined by Ian Tattersall there, formerly called the evolutionary species concept, is practically how we recognize species. For instance, lions and tigers can interbreed, and sometimes they form viable, fertile offspring, and yet we still consider lions and tigers to be distinct organisms. It goes without saying, but part of the problem here is that reproductive isolation is messy and often incomplete, particularly when species are in the middle of forming. So now we might ask ourselves, are Homo neanderthalensis, is the Neanderthal a distinct species from Homo sapiens under Ian Tattersall's definition? Keeping in mind that if you want to force the biological species concept as a creationist here, you have to accept that lions and tigers are the same species. But yes, Neanderthals and humans are in fact distinct, separate species. Neanderthals split from Homo heidelbergensis before our own species did, some 800,000 years ago, along with their closer relative, Denisovans. Homo sapiens, comparatively, did so some 350,000 years ago. So temporally, Neanderthals are indeed distinct, but do they have their own morphology that necessarily defines them as unique from our own species? Absolutely 100% yes, they do. So in evolutionary terms here, we're going to be discussing some of the Neanderthal autapomorphies. And autapomorphy is a derived characteristic that is specific to the species that you are considering then and there. They define that species, as in if you dig up a bone, an autapomorphy can clock that species as that species to the exclusion of absolutely everything else. So, hello, I am here with some of my specimens. We're looking at Homo sapiens here and a Neanderthal cranium here. This is specifically La Ferricie 1, and what I'm going to do is walk you through some Neanderthal autapomorphies by looking at the cranium, right? Looking at the cranium of Neanderthal as well as the mandible and comparing that to that of Homo sapiens. So I'm going to try to speak loudly, but my head is mostly going to be out of frame because I've got to gesture at these guys and poke and prod at them and caress them. So Mike's here, specimens are here. We're going to do what we can with what we got. So first things first that I hope you notice is Neanderthals have a very large and doubly arched supraorbital torus. So the supraorbital torus, all that is just the brow ridge, right? So these are the orbits, and torus means like bar or shelf. So supraorbital, above the orbit, brow ridge. And you can really see that as compared to Homo sapiens when you turn them to the side like this, and you can appreciate that Neanderthals really just have this massive shelf of a brow ridge compared to Homo sapiens, and this is a male, and males typically have a larger brow ridge than females do. although not always. They also have a narrower face with like sharply retreating zygomatic bones. So your zygomatic bones are your cheekbones. You can feel them if you put your finger sort of like where your cheekbones are. Like Angelina Jolie's got really great zygomatics. That's why I always try to get my class to remember it. But the zygomatics are here and here on Homo sapiens and Neanderthals respectively. And even from this angle, you can see right away that the Neanderthal zygomatics are really swept backwards. It looks as if you've taken the Homo sapiens condition and pulled those zygomatics backwards to give it a sort of windswept look. And what this means is that when you look at them from above on Neanderthals as compared to Homo sapiens, you end up with like almost like a more pronounced prognathism. And there's going to be pronounced prognathism on Neanderthals sort of aside from that, but this is an illustration that I use in my class comparing Cro-Magnon or Cro-Magnon to the skull that we're looking at for Neanderthal here. So La Ferracie, same as the model. And as you can see, an inferior view here, those swept-back zygomatics are just incredibly characteristic. Really, I think that inferior view reveals quite nicely how different these two guys are from one another. Anatomically, modern Homo sapiens being our stand-in for Cro-Magnon, and the La Ferracie model is the same as in the picture. But man, you can just see the robust nature of Neanderthals as compared to Homo sapiens. They are striking when compared to one another. Neanderthals also have a very large nasal aperture or nose hole as compared to Homo sapiens, and that's not just because we're missing the nasal bones here. That huge nasal aperture as compared to what we see in smaller Homo sapiens here is thought to be for the purposes of cold adaptation, because the bigger your nose, the faster you can warm up air so it doesn't freeze your lungs solid. So they would have had big honking noses in addition to every other kind of odd feature about them. Neanderthals also have a platycephalic skull. So platycephalic means kind of like a squished back and flat, platy meaning flat. And what you can see when you look at these guys, comparing them side by side sort of in profile here, in a sagittal view, if you will, is that Homo sapiens has this globular brain case size that's quite round and tall. The forehead itself is very tall, as compared to Neanderthals, whose skull shape is platycephalic. Their skull is very low and long, the cranial vault is, and as a result, it almost looks like you've taken the human condition and squeezed it and pulled it back and squished it down in the front. That means Neanderthals are missing that vaulted forehead that's characteristic of Homo sapiens. They couldn't wear a ball cap. If they tried to, it'd fly right off the top of their head, which is a funny, if a bit sad image. So you can't see it very well on this particular Neanderthal specimen just because this is a bone clone, not a cast, or obviously the real thing. Can you imagine? But on humans, as compared to humans rather, the Neanderthal, if you could see it quite well, they have, as compared to the humans, and you see a squamosal suture here, in Neanderthals there's an angling along the squamosal suture that divides the temporal fossa into clearly demarcated anterior, so front-facing, and posterior portions. So it's just unique aspects to their cranial sutures. Neanderthals have a very unique structure at the posterior portion of their skull, specifically around the occipital bone, that is understandably called the occipital bun. And when you see the occipital bun described, you'll sometimes see people talk about like a pitted suprailiac fossa that's going to lie above the occipital torus or the occipital shelf here, which, you know, I don't really see it that much. I see the occipital bud really clearly, but I'm not 100% sure. I've never had it pointed out to me very clearly, this fossa that people tend to point out. And that's compared to a complete lack of an occipital bun here in anatomically modern Homo sapiens. There's just nothing of the sort. Neanderthals are really prognathic compared to Homo sapiens. So prognathic just means general snoutiness. And when you look at like Homo sapiens here, you can see that the face, the mid-face here, is tucked right below the skull, right below the frontal lobe here. Everything is kind of just squished up underneath. If you were to take a pencil and mark it on the nasal bone, you might hit the teeth, but there's really no clear muzzle. And some people are going to be, there's variation there, right? Some people are going to be more prognathic than others. It doesn't mean anything, but no one is going to be as prognathic as Neanderthals, Homo neanderthalensis, because the reason why their faces jet out so much more than we do is, again, it's emphasized by those swept-back zygomatics, sweeping zygomatics, but they also have like inflated maxillary sinuses here that seem to push the face forward. Again, I think that makes sense, right? Having inflated maxillary sinuses is going to benefit an animal that's living in really cold climates because there's just a lot more surface area to begin to warm the air for these guys. Neanderthals are generally characterized by having these more oval-shaped foramen magnums, and I don't really see it looking at these models myself, so it's possible that this model just isn't a good enough model, like it's not nailing that sort of oval shape. The foramen magnum, again, is this hole at the base of the skull, and I don't think there's like a functional reason proposed for it being more oval-shaped in Neanderthals as compared to Homo sapiens, but that is the argument that's made. You can point to a lot of minutiae in the crania here, right? Like Neanderthals are proposed to have a pneumatized petrosal, so that's the a portion of the temporal bone that is proposed to be pneumatized. I think they provide pretty good support for it. You really just have to CT it. That just means that it's got a lot of like little air-filled cavities. I can't imagine what that might be for. There's a lot of minutiae that you can point to in the nasal aperture with like the, lack of a better term, like the nasal conchae, things of that nature, but you're not going to see them very well on this model here, and I also don't think that you guys are going to care very much. So to summarize the differences in these two crania, right, in the two skulls, in the way that I teach my students, in a way that I think is most memorable, Neanderthals have a prominent brow ridge, a large nasal aperture, tapered orbits, swept back zygomatics, and the presence of an occipital bun in combination with a very unique cranial vault shape that is platycephalic, like low and long, and a non-vaulted forehead. So you can combine all of those things together and say those are Neanderthal autapomorphies. I often see creationists will point to living people, like with a big brow ridge or something like that, and they'll say, see, that looks like a Neanderthal, that guy looks like he could be a Neanderthal, therefore the morphology that defines Neanderthals is not sufficient. They're not a sufficient suite to distinguish them.
I mean, we could point to, and you have pointed to in previous presentations here, to actors, boxers. There's one specific Russian boxer, Nikolai, I think his name is, where they have that distinct Neanderthal trait in the brow ridge. So modern day people have Neanderthal traits.
But I'm really sorry, a brow ridge is one characteristic of dozens of autapomorphies, and I'm only listing a few here. There is not a human alive that has more than 5, I would say. It's a ballpark swing, and I bet most of them are minute. There's not a human alive that has the combination that I just mentioned going over this now. And if I'm wrong on that, all you gotta do is show me the skull. So let's move on to the mandibles. So in comparing a Neanderthal mandible to a human mandible, there are a few things that I point out to my students right off the bat that I think are really important. One is a Neanderthal autapomorphy called a retromolar gap. This means that there is a space behind the last 2 molars, or last 2 molars, one on either side. The last molar, the third molar here, where you can lay your pencil down and it can just pass right through it. It doesn't have to burrow through the ramus of the mandibles, the hinge of the mandible here. You can just lay it down. A retromolar or behind the molar gap. This is compared to Homo sapiens, which doesn't have a retromolar gap. I can't stick my pencil or my little indicator here behind because that last molar is seated so far back in the jaw there. There's just no retromolar gap. That's Neanderthal only. There's also a comparison that you can make between the two of these guys that is a human, a Homo sapiens autapomorphy to the exclusion of Neanderthals, and I think it's worth mentioning just because if you pull a mandible up out of the ground, humans are going to have this and Neanderthals aren't. And that's the presence of a chin. Not a chin like, a Wojak lack of a chin, where like somebody has this seemingly receding chin, but this bony protuberance, this bony shelf that you can see right there. All humans, even ones who don't seem to have very strong chins, are going to have that, with the sole exception, I believe, of like a pathologic condition. I'm allowing for that. I don't think that exists, but, it might. Neanderthals lack that, right? There is no presence of a chin on this Neanderthal jaw, on this mandible here. It is just straight up and down. So when you compare the autapomorphies just within the mandible, Neanderthals have a retromolar gap. Homo sapiens doesn't have a retromolar gap. Homo sapiens has a chin. Neanderthals don't. But there's a lot of minutiae that we could go over with the jaw, right? Like, those are just the autapomorphies that I teach my students. The bone in front of the mandibular symphysis, which it's not preserved very well at all here in Larfurus C1, it seems to be obliterated, but the mandibular symphysis is the fusion of the mandible that occurs here at the front. In humans, this bone over the mandibular symphysis or near the mandibular symphysis is like really thick, and in Neanderthals, it's considerably thinner. Neanderthals have larger molars. I think that makes sense. They've got more robust jaws in general. Golly, this angle makes me look like Megamind. And they also have aspects of their molars when you like CT scan them and you actually take a look at the molars themselves. They have what's called taurodont molars. I'll put an image up so you can see what I mean. But basically you can think of it like the roots are really fat. I don't really know how else to describe it, but it's unique to Neanderthals, like to the degree that we see it. Their incisors have beveled wear. That's more of a behavioral thing, right? That means that they're wearing their incisors in a really weird way. When you look at this from the side, you see that the wear kind of falls backwards like this, as if they're taking something. This is like the idea. They're taking cloth and holding in their teeth and pulling it downward for maybe tanning hide or something. It's like, excuse me, I'm going to show you with this pillowcase, but like, kind of like that, you know? And then as it pulls down, it wears on that enamel of the lower incisors, the mandibular incisors, and creates that beveled wear. So all of this that I've talked about so far could pretty much fall into the category of like the general differences. Again, there is just so much we could talk about with regard to the minutia that I can't talk to you about here, either because this is a basic bone clones model that doesn't preserve them if it's exterior, because it's literally inside the skull. So, you know, I hope I don't need to tell you this, but you've got a lot going on inside your noggin that is pretty important, and that, you know, all of these are individual little osteological landmarks that are really important. And nerves pass through, cranial nerves pass through all of these different fossa and things and holes and stuff like that, all inside your skull. Neanderthals and humans obviously differ in a lot of little minute aspects that I can't go over with you here. And some of these are also, like, you would require a CT scan to see. So I just want it to be emphasized, right, that this is just scratching the surface of the craniodental differences. But there's one more that I want to talk about that I think is really important, because I hear creationists use it all the time, or attempt to use it all the time, with regard to the Australopiths. So inside your ear, inside the external auditory meatus, the ear hole here, if you travel long enough and you stick like a Q-tip in there, you can scrape your tympanic membrane or your eardrum. If you perforate the eardrum and go past it, then you have your auditory ossicles. These are your three inner ear bones, your malleus, your incus, and your stapes. And these guys are going to interact with like the cochlea through the oval window and things like that. You've also got your semicircular canals back there, which are responsible for your vestibular system, your balance. The thing about those semicircular canals is they can tell you a lot about how a critter moved, because obviously the type of balance and proprioception required for an arboreal animal is very different from a terrestrial one. And so we can look at the semicircular canals and we can tell a lot about how a critter moved. Australopithecus have semicircular canals that show that they still maintained an aspect of arboreality. That makes sense. It matches a lot of what we see in the rest of their bodies, but you could still be in the trees and be like a biped on the ground, and what their morphology tells us is that they were primarily bipeds that still stayed in the trees some of the time. Case in point, the semicircular canals don't look like Miocene ape semicircular canals. They just look more like Miocene ape semicircular canals than they do like those of humans. Humans have the semicircular canals of like a terrestrial obligate biped. Neanderthals are interesting because Neanderthals have semicircular canals that are also very different from humans. That's important for the creationist conversation, because creationists will point to the different semicircular canals that Australopiths have and use that to say, no, clearly they're just glorified chimps, because they know nothing about the morphology of those hominins. But I'm going to read a quote for you here, because I think it's an important one, by Spohr and colleagues in 2003. The labyrinth of the middle ear of Neanderthals is so distinct from that of modern humans so as to suggest, quote, differences in locomotor behavior and the kinetic properties of the head and neck. So the Neanderthal semicircular canals are also really different from those of humans. You can't use them to separate humans from Australopiths, because doing so would also separate Neanderthals from humans. When all is said and done, you're just not going to be able to look at these two crania and tell anybody that they are clearly the same species. Not when we have so many other examples of far more similar crania belonging to different species. Post-cranially, though, Neanderthals differ as well. They have thick-walled long bones with restricted medullary cavities and expanded articular surfaces. They have long scapulae, the shoulder blades with expanded rotator cuff attachment areas, and long, narrow glenoid fossae. They have long clavicles with relatively flattened shafts. Their pelvises have flaring iliac blades and long, attenuated pubic rami. And their hands are different from ours, with large carpal tunnels, expanded pollicle and ulnar distal phalangeal tuberosities, and generally accentuated muscle attachment site areas when compared to humans. In overall form, Neanderthals have enormous barrel-shaped chests which taper at the top and the bottom, broad shoulders and pelvises, and shorter waists. In this way, they've been described as being hyper-Arctic, having a body that seems to have put Homo erectus through Allen's rule. Ian Tattersall points out, quote, "The sheer scale of the morphological differences between the Neanderthals and Homo sapiens makes it vanishingly implausible that both could fall within the envelope of morphological variation within a single species," unquote. Tattersall has also pointed out in the past that if we're being consistent across the entirety of the animal kingdom, you wouldn't place Homo sapiens and Homo neanderthalensis just in different species, but actually in different genera. That's how stark the morphologic differences between them truly are when you tally all of them up instead of just eyeball it. This might be a bridge too far given what we know currently. I might compare it to lions and tigers, which differ on the species level but share a genus. They can produce offspring pretty successfully, and the offspring can be fertile but isn't always. This is compared to African and Asian elephants, which differ at the genus level, Elephas maximus versus Loxodonta africana, and rarely, if ever, can they produce a viable calf. Neanderthals and Homo sapiens are a lot more like the former pair, mostly fertile but on the way towards reproductive isolation. Definitely different species. All of this to say that if we are using morphologic criteria here, Neanderthals for sure are a different species as compared to Homo sapiens. None of this is to debase Neanderthals, however. These hominins were ridiculously successful and had their own unique societies, technologies, and cultures. They lived on Earth for nearly double the amount of time that Homo sapiens has been around for, and they did so in a very rough and tumble environment. The fact that we, Homo sapiens, are here and Neanderthals are not is an open question. It could be that we outcompeted them, it could be that we outfought them, it could be that we outbred them and simply incorporated them into us. But it could also be that it was almost entirely, if not entirely, luck-based. Maybe it was that they couldn't innovate as quickly or as easily as Homo sapiens could, and when the climate changed, they simply couldn't change with it. I don't think that Homo sapiens is, superior necessarily to our Neanderthal cousins. I don't think the support exists to say that with any certainty yet. And what that means is that the fact that we're here and they're not may just be simply due to a couple of very key differences or very chance events. A few things could have swung a different way, and maybe it would have been a Neanderthal world. However, appreciating this species does mean appreciating what makes them similar to us, as well as what makes them distinct from us. While morphology does an excellent job visually displaying this, only genetics can outline the details, that their genomes are unique and where they are on our family tree. So as mentioned previously, we've sequenced over 24 Neanderthal genomes, and from this, we know that they are 99.7% similar to us looking at the protein coding regions. This is compared to the 99.9% similarity that the two most different humans get for one another, and the 98.8% similarity that any given human will have to any given chimpanzee. We also know from their genomes that humans and Neanderthals in the past, so archaic Homo sapiens and Homo neanderthalensis, were capable of interbreeding with one another and, in some cases, producing viable fertile offspring. However, the fact that we don't have any modern Neanderthal mitochondrial DNA in us today suggests that there was probably some element of hybrid sterility. The argument goes that that may suggest that we were capable of producing hybrids if the male or if dad was a Neanderthal and the female or the mom was a Homo sapiens, that pairing could produce fertile offspring, but female Neanderthal, male human couldn't. But there are other explanations, so the reality of that remains to be seen. We also know from their genomes that Neanderthals, particularly late in their species tenure on Earth, were incredibly inbred. And as previously mentioned, this is probably because early on they were already living in small groups that were relatively far apart, and as they began to go extinct, these small groups were further and further isolated from one another and were forced to inbreed as a result. So I just spent a lot of time talking about Neanderthal morphology, specifically their autapomorphies and what makes them distinct from every other hominin, and to be perfectly honest, Young Earth Creationists hardly know anything about that at all, so they never touch it. They just say they look human enough, and they call it square. No, instead the arguments that they primarily make come from the world of genetics. This is actually great for us because most of the predictions made by both the truncation and degradation model and their shared predictions are rooted in genetics. Most of those arguments are genetics-based. We can provide support for Neanderthals and Homo sapiens not being the same species by pointing to morphology as we previously did, but for the remainder of these predictions, we're going to be using genetics. We already answered this question using morphology, but since both models predict that Neanderthals and humans should be the same species, we must ask the question, what does genetics say about this prediction? It's abundantly clear to you if you watch my channel at all, but I'm like a morphology person and a behavioral ecology person. I don't do very much with genetics, and I've had to learn a lot about it as this channel has grown through the years. This section that's coming up, this entire piece on genetics, is drawing heavily, if not entirely, from the work of a few friends of the channel, Dan of Creation Myths. Dan is an evolutionary biologist, and of course Walker of Just a Walking Fish. Walker is currently a graduate student for paleogenomics, so I very much trust the opinion of both of these guys. Both the mitochondrial genome and the nuclear genome for Neanderthals are incredibly well characterized, and what that means is that we can say with pretty decent certainty where they fall and how similar they are to Homo sapiens. In one of the earliest works on the subject as far as like a decent amount of data goes, Briggs and colleagues in 2009 sequenced 5 Neanderthal mitochondrial genomes and compared them to 53 humans, anatomically modern Homo sapiens, across numerous different language groups. The resulting phylogeny reveals 2 monophyletic sister groups, Neanderthals and Homo sapiens, being clearly separate species. The asterisk at each node here denotes a probability of 1. This means the probability that Neanderthals nest within Homo sapiens, according to that data set, is 0. This means, according to those mitochondrial genomes, the probability that Neanderthals are Homo sapiens is also 0. POTHS in 2017 found exactly the same thing, recapitulating the former's mitochondrial results. But the crown jewel was 1 year after that. I guess everyone had just been sitting on their data, tinkering away to come out with this bombshell paper, because in 2018, Hajinjak, which I hope I'm saying correctly, and colleagues did another phylogeny. Actually, they did several, including mitochondrial, Y-chromosomal, and nuclear phylogenies with an increased sample size as compared to previous work, and found that in all 3, unequivocally, Neanderthals fall outside of Homo sapiens. They are a sister species. So all 3 of those papers came from a debate that my friend previously mentioned Walker had with a Young Earth Creationist, and he used all 3 of them in his opener. I thought they were phenomenal, especially put all together like that. But I'm going to put a clip here about that previous paper because Walker has a little elaboration on it. He did a little bit of extra legwork, which is funny because he's a walking fish.
So here's my absolute favorite thing. That last paper actually provided the z-scores in the supplementary information. The z-score, the lowest z-score, or the best case scenario for you, was negative 36.63. This gave a p-value of 4 times 10 to the negative 236. This means that picking an atom, a specific atom at random from anywhere in the observable universe 3 times in a row is about as likely as these groups not being monophyletic. Once again, this was the best case scenario. Worst case scenario was a z-score of negative 68.97. So naturally, I didn't even bother to do the math. As much as we can possibly know anything, these two groups are independent monophyletic lineages.
This is stupid game. It does not work. The logic is really not right.
Wow. Yikes. I think we're pretty good to say that Neanderthals and Homo sapiens aren't the same species at this point, but there's actually an even bigger implication hidden in those three papers. For now, I'll just say this. This prediction by both creationist models fails utterly when put up against genetics as well. Morphology and genetics both determine that Neanderthals and humans are separate species. So you might hear this and think, okay, cool, so game over. The Neanderthals and humans are separate things, and creationists lose on this one, just like they've lost on everything else. We're through here. But not quite, because they have some counter arguments that they want to make while simultaneously just kind of generally ignoring the human variation problem there. The percent similarity number, again, is gleaned by having the sequenced genomes of over 24 Neanderthals and tens of thousands, if I had to guess, of people. And the way you can imagine this is if you sequence the genome of two parents, a mom and a dad, and their 5 biological children, and then you sequence the genome of a cousin, all 5 of those biological children are going to be very, very similar to one another and to their parents, and if you plot them all on a pedigree, the cousin is going to fall out off to the side. This is precisely what happens when you compare these sequenced genomes of Neanderthals as compared to humans. Every single Neanderthal falls outside of the variation of Homo sapiens. Bringing this back to our lions and tigers example, despite the fact that the two can interbreed and sometimes produce viable offspring, they are clearly different morphologically, and they fall outside of one another's range of genetic variation, further warranting their designation as separate species. So the fact that Homo sapiens has this set amount of variation in it, and that Neanderthals have a set amount of variation within them, and that their set of variation falls outside of the human set is important for this idea of separate species or a same species. But there's another important piece of the puzzle with this level of variation between these two taxa, and we're going to come back to it later because it has catastrophic implications for the truncation model. The degradation model does not get off scot-free, no. In fact, the issue that we're about to talk about with regard to it directly corresponds with a very clear prediction that the degradation model makes as to how we get Neanderthals. And that prediction is that Neanderthals have descended from Homo sapiens as a species, meaning Neanderthals should nest within Homo sapiens. In our cousin-sibling-parent analogy here, it would be the 2 parents and then the 5 siblings, and then the cousin should come from one of the siblings. I was gonna do some drawings myself, but Dan already beat me to the punch, so make sure you're subscribed to both Just a Walking Fish and Creation Myths for me, please. In Dan's figure here, we can see the YEC prediction quite clearly. Neanderthals nest within Homo sapiens. They are descendants of Homo sapiens. Homo sapiens existed first, and Neanderthals come from them. The evolutionary model, on the other hand, predicts that Neanderthals should be a sister group to Homo sapiens because we share a common ancestor in the form of a more basal hominin. Again, under the degradation model, Adam and Eve are Homo sapiens. That is the proposition. And so every other hominin that is a part of the quote-unquote humankind must descend from them and necessarily nest within them. It's important to note that this is specifically a prediction of the degradation model, as I said earlier. The truncation model is going to look exactly like the evolutionary prediction, at least at first glance, with no time considered. Because if Adam and Eve can be Homo heidelbergensis, then the truncation model would predict, similar to the evolutionary model, that Neanderthals are not going to nest within Homo sapiens, and neither are Denisovans. They're all going to share a common ancestor in the form of Adam and Eve, who are heidelbergensis. We have a really big problem here if we are degradation model Young Earth creationists, right? Because again, Neanderthal genomes have been sequenced, and so have the genomes of many, 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 many Homo sapiens. And what that means is that we can create a phylogeny based off of those genomes and find out who falls where, just like a regular old run-of-the-mill human pedigree. Again, as a crude analogy, the way that a pedigree is created is by sequencing a genome and looking at how similar genomes are. Necessarily, human individuals who are more similar genomically are more closely related than those who are not. Every pair of siblings is going to have more in common genomically than any of those siblings will have with their cousins. All of that being said, a lot of you probably already know where this is going and have already thought back to that last of 3 papers from roughly 5 to 10 minutes ago, depending on how this editing hashes out. Because not so shockingly, the same data that show that humans are separate from Neanderthals reveals that Neanderthals nest outside of humans, whether we're looking at modern humans or including archaic ones. Because wouldn't you know it, if your variation pool excludes an entire separate pool of variation, when you plot that phylogenetically, they're going to appear as sister groups. Crazy. Whether we're looking at mitochondrial, Y chromosomal, or nuclear genetic material, every single time Neanderthals are not nesting within Homo sapiens. They do not descend from them definitively. These degradation model young earth creationists have tried to weasel their way out of what the data says by saying, well, it may be that Neanderthals are incredibly distinct genomically, but that's just because they're hypermutating and also inbreeding. And I know what you're thinking if you've been paying attention this whole time. Even if they were hypermutating, that wouldn't solve the problem of them not nesting within Homo sapiens. It would just make the phylogeny look a little different. To steal another one of Dan's figures, the Neanderthals would still nest within Homo sapiens, they would just have a lot longer branches. And I'm sure you've no doubt caught the other problem with this idea of post-Babel hypermutating and also hyper-inbreeding Neanderthals, and that's that you can't be hypermutating and also inbreeding. They are definitionally opposites. Within our mechanisms of evolution here, to harken back to Biology 101, mutation is one of the mechanisms, and it's known for increasing genetic diversity. On the other hand, the founder effect, a type of genetic drift, and another word for inbreeding, is known for definitively decreasing genetic diversity. So you can't have a population that is simultaneously hypermutating, increasing its diversity, and also inbreeding, decreasing its diversity. Now, it's absolutely true that Neanderthals at the end of their species tenure on Earth were incredibly inbred. As I said previously, we're talking about a group of animals that didn't have very many members of its species on the Earth's face at any given time, like 10,000 to 15,000 individuals. They already lived in small groups that were super spread out. So as they began to go extinct locally, they began to have these small groups they already lived in be separated by more and more space. They're more and more isolated, and inbreeding becomes more and more common. This much is very true. However, while Neanderthal genetic diversity as a whole is lower than Homo sapiens genetic diversity as a whole, when you look at Neanderthals living in the sort of European area and compare it to the Homo sapiens that live in that area today, Neanderthals actually have slightly higher genetic diversity. Here is Walker to explain in a clip that I took from another cool video on his channel, because he doesn't make videos anymore.
Individuals from the same site revealed very low genetic diversity and close kin relationships, while the total genetic diversity across all the Neanderthal sequences we have was actually greater than the total diversity of modern humans that inhabit the same region today, both based on mitochondrial DNA. This, taken together with the very small effective population size, supports the hypothesis that Neanderthals lived in small, highly inbred groups, and these groups were relatively isolated from the other Neanderthal groups.
So, highly inbred? Yes, absolutely. Exceptionally so? But what about hypermutating? Were Neanderthals hypermutating? Because as I said earlier, we've observed lineages that hypermutate, so to speak, and as a result, we know what that looks like. Do we see it in Neanderthals, remembering, of course, what type of phylogeny that would produce? No, we don't see hypermutation, not in the nuclear genome and not in the mitochondrial genome. I'm comparing these two in particular because upon the last time that we pointed out hypermutation doesn't happen, the response by some creationists was that actually only Neanderthal mitochondrial DNA shows hypermutation. Inbreeding in the nuclear genome masks it, except here we see hypermutation exists in neither. So what I'm saying is, the prediction by the degradation model that Neanderthals should nest within or descend from Homo sapiens does not pan out. So the degradation model is looking pretty rough, right? Neanderthals and Homo sapiens are not the same species. Neanderthals don't nest within Homo sapiens, but it's time for the truncation model to take something of a beating. And unfortunately for the degradation model, it also is going to take some licks on this one as well, because both models explicitly propose that this should all be doable within 6,000 years, because remember, these are young Earth creationist models. So genetic diversity is caused by mutation. I should say generated by mutation. Mutation is one of our mechanisms of evolution, and the last common ancestor of all living humans from a mitochondrial perspective, our mitochondrial Eve, has been suggested to have lived around 200,000 years ago, given known mutation rates. And that's really going to be the time limiter here, right? That rate at which you can generate mutations is going to tell you how fast or how slow you can generate diversity in a given population, in a given species. So you can see that the young Earth creationists have their work cut out for them, because the mitochondria is one of our better case scenarios for them as far as generating diversity quickly, and even that's 200,000 years. They need it in 6,000. They need all human diversity in 6,000 years, which is why, ding, 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 we had that hypermutation concept from earlier that has no support for it whatsoever when we look at genomes. And it's for this reason that young Earth creationists have tried to sort of cook the books with regard to mutation rates in order to explain how you get all modern human diversity in just 6,000 years as opposed to 200,000. You have that hypermutation concept, and then you have the likes of Nathaniel Jeanson, the creationist who wrote Replacing Darwin, who gets these ridiculously fast mutation rates and proposes that mitochondrial Eve lived approximately 6,000 years ago, except amongst many other methodological errors, his primary issue, the glaring, massive mondo giga problem with his work, is that he generates those mutation rates by using a mutation rate, not a substitution rate. And before you say to yourself, no, there's no way he wouldn't do that, here's friend of the channel, Dan of Creation Myths, talking to Jeanson himself about this, along with some clips of his sort of debrief afterwards.
Let me again derive how I'm getting to this point. So we've got my claim from the examination of the published literature that the mutation rate is 3 mutations per generation, and I'm treating the mutation rate as a substitution rate, that this rate is consistent.
Thank you. Thank you.
That's what I'm doing.
What the hell is that?
The mutation rate is by definition significantly faster than the substitution rate, because the substitution rate is the rate at which mutations fix and become a part of a population, not just the rate at which they happen. And it is the latter that contributes to genetic diversity within a population, not the former.
He arrives at a date of about 6,000 years and about 4,500 years ago for those two measures, in contrast to the consensus dates of 1 to 200,000 years ago for the mitochondrial DNA and 2 to 300,000 years ago for the Y chromosome. This methodological bait and switch is the linchpin of Jeanson's work, and more broadly, all the young Earth attempts to fit the breadth of human genetic variation into a young Earth timeline. Openly admitting the move ends the debate over whether these calculations, and by extension the young Earth timeframes for genetic divergence in Homo sapiens, are valid. The answer is that they are not.
That was an absolutely horrendous performance from start to finish. That was a masterpiece of dog shit.
I'd like to take a minute here to note that some young Earth creationists tried to propose that the phylogenetic rate being necessarily slower than the pedigree rate is only a conclusion that we reach through evolutionary assumptions. This is not the case, and here is Dan of Creation Myths yet again to explain why.
They claim that these studies prove most recent common ancestors for the mitochondrial DNA and the Y chromosome. There are many problems in how they do this, including misrepresenting most recent common ancestors, ignoring autosomes, treating mutation rates as substitution rates, ignoring direct, independent confirmation of phylogenetic rates, counting somatic mutations, extrapolating the hypervariable region, and doing hilariously incorrect, let's call them calculations. But putting that all aside, we only focused in this video on how they cherry-pick single-generation pedigrees and ignore multi-generation pedigrees that disprove their recent dates for the Y chromosome and mitochondrial most recent common ancestors.
My favorite reason that Jeanson is wrong, which has also been proposed by Dan, is that we know from looking at phylogenies of living people groups who have settled areas of the world recently that the phylogenetic rate is far more accurate over long time periods. Case in point, the Canary Islands. One thing that's interesting about Nathaniel Jeanson is that he explicitly doesn't include Neanderthals when he is trying to calculate the date for mitochondrial Eve and Y chromosomal Adam. His reasoning for this is that you can't trust the ancient DNA that we pull out of Neanderthals, which is kind of ridiculous because all of the genomes that we sequence are very, very similar to one another. Remember, they're quite inbred, which I don't think would be the case if they were too degraded, as Jeanson likes to propose. And it's for this reason that most other young Earth creationists accept the validity of Neanderthal genomes as like a real, genuine snapshot of what the genomes of these guys looked like. A lot of those same creationists, however, will, while not accepting Jeanson's verdict on Neanderthal ancient DNA, will still use his work on mitochondrial Eve to prop up the idea that genetics supports young Earth creationism. Can you see where this is going? Yeah, they say, that Jeanson, he's being a little too hard on that Neanderthal ancient DNA. I think it's great support for creationism. It shows how truly human they are. But I do like that Nathaniel Jeanson's times to most recent common ancestor for mitochondrial Eve that shows the Earth is 6,000 years old by showing that the common ancestor of all living Homo sapiens is from 6,000 years ago. Remember what I said about Neanderthal genetic diversity being outside of human variation? And remember what I said about how it takes time to accrue mutations and genetic diversity in the first place? Nathaniel Jeanson calculates the time to mitochondrial Eve by looking at modern human diversity and trying to track it backwards, even though he's doing it completely wrong. Conceptually, that is what he's doing, but only Homo sapiens. Necessarily adding Neanderthal genetic variation to that calculation is going to push the date back, because if you need 6,000 years just for Homo sapiens, you need even more for Homo sapiens plus Neanderthals, and even more for Neanderthals, Homo sapiens, and Denisovans, and even more for Neanderthals, Denisovans, Homo sapiens, Homo heidelbergensis, and so on and so forth. Meaning that the truncation model can't be a young Earth creation model. If you believe that Adam and Eve are Homo heidelbergensis, or Homo erectus for that matter, you can't believe the Earth is 6,000 years old, because there isn't a calculation out there that can give you the genetic diversity that you need in just 6,000 years. And that includes the faulty calculations by Nathaniel Jeanson. But then you also can't propose that Neanderthals descend from Homo sapiens either, because they demonstrably do not. So we're really getting two predictions of the truncation model and failing them here, as well as a single prediction of both models. This is not looking good. However, remember, evolutionary theory predicts that Homo sapiens and Homo neanderthalensis share a common ancestor, and that common ancestor was approximately 400,000 years ago. That is plenty of time to accumulate all of the diversity between both species. And then the common ancestor of all of Homo sapiens, looking at mitochondrial DNA, is approximately 200,000 years ago. Again, we have plenty of time. We see Neanderthals nesting outside of Homo sapiens, and we see Denisovans also nesting outside of Homo sapiens and closer to Neanderthals than to us, all exactly as expected. I've also talked about it before on this channel, but there is no way to get human origins to not be in Eastern Africa, right? Every single time, that's where it lands us, whether we're looking at phylogeny, linkage disequilibrium, or homozygosity, it lands us there every single time, distinctly not in the Middle East. When all is said and done, Neanderthals cannot fit within a young Earth creationist time frame. They are not Homo sapiens. They are something distinct, an animal that represents a unique evolutionary pathway and a different way to be a member of genus Homo. They are human, but they're not Homo sapiens. This is revealed by their behavior, by their morphology, and of course by their genetics. And that latter category also reveals that these guys cannot fit within 6,000 years, nor can they fit with a Tower of Babel or Noah's Ark event. Neanderthals nest by themselves. They are highly inbred at the end of their tenure on Earth, but not hypermutating. They are not degraded, but well adapted for their environments. They are monophyletic and genetically distinct from Homo sapiens, and the genetic diversity that they have simply cannot be generated alongside that of Homo sapiens in a mere 6,000 years, even using broken methods, which is why I suspect Jensen doesn't trust their aDNA. These guys descend from an earlier hominin that had roots still back in Africa and also migrated into other parts of the world. It evolved in Eurasia and was extremely successful there. And evolutionary theory makes an interesting prediction here to the exclusion of young Earth creationism, and I want to investigate it briefly here at the end. Neanderthals have many characteristics that appear to me to be more basal compared to anatomically modern Homo sapiens. Now, both Homo sapiens and Neanderthals have these autapomorphies that define their species, as we talked about earlier, but I do think it's reasonable to claim from an evolutionary perspective that there are going to be some regions of the genome where Neanderthals are more similar to chimpanzees, regions perhaps where both haven't changed since the last common ancestor between hominins and panins and Homo sapiens. Similarly, there should be a few regions where Homo sapiens retains the more ancestral condition as compared to Neanderthals. I made the claim in a previous video that I would propose that archaic Homo sapiens and Neanderthals alike should have a more basal-looking human chromosome 2 fusion site as compared to anatomically modern Homo sapiens, and I was right on that. Crickets on that one, boys. Haven't heard a response yet. And I think that's important, like, as a prediction, because young Earth creationism would, and indeed hasn't predicted anything of the type, anything of the sort. Why would they suspect that more basal hominins would share more in common with chimpanzees than more derived hominins? Well, they wouldn't. And they haven't. So I want to point to one last lovely little snippet from a paper found by Walker, and I'm just going to pull it up here and read it to you. So I'm covering poor Walker here, but this is from Walker's debate with the creationist I told you about, and he's quoting from a paper here titled The Divergence of the Neanderthal and Modern Human Y Chromosomes. And this quote is talking about several different SNVs, of single nucleotide variations, I think it is. I usually see SNPs, but I think this is similar. Geneticists correct me, rake me over the coals. And what they're looking at is Neanderthals, so represented by Neanderthals, chimpanzees, the A0 haplogroup, which is one of the earliest diverging groups in modern humans, and an anatomically modern human, so modern reference genome. They identified 24 biallelic SNVs for which the Neanderthal sequence shared the chimpanzee allele and differed from both archaic Homo sapiens and the human reference. In contrast, the chimpanzee and archaic Homo sapiens sequences shared just 4 SNVs not present in the other sequences, and the chimp and the anatomically modern Homo sapiens sequences shared 0. So chimps and Neanderthals are sharing 24, archaic Homo sapiens and chimps are sharing just 4, and modern humans and chimps are sharing 0 for this series of SNVs that they're looking at. This is what evolutionary theory predicts, not young Earth creationism, not in any shape or form. And indeed, I've never seen that prediction from any of them. So, gold standard of science and all that. I think it's worth noting here too that all of that phylogenetic work from earlier, like all of those different phylogenies that we touched on, the relative similarity between humans and Neanderthals, basically all the genetic work here, none of it assumes human-chimp common ancestry. That is a very, very important point to make, because one thing that creationists will try to throw at you to invalidate everything that I've said here is, oh, well, you only got that because you assumed humans and chimps are, like, together, they share a common ancestor. No. We're assuming none of that to get to this. It's not necessary. Anyways, you guys, I think I've done a sufficient job here sort of collating all the information out there to explain why Neanderthals do not at all in any universe fit into a young Earth creationist worldview. You cannot make them work. No matter how many times you hear them say Neanderthals are just humans, they are not going to be force fit into a 6,000-year Earth. Full stop, period. That's the end of the story. None of the creationist predictions with regard to Neanderthals have panned out. They can't even be retroactively accommodated in the young Earth creationist worldview, which is why they rely so heavily on just showing you recreations of Neanderthals and being like, see, he's just a guy. He's just like you and me. And Neanderthals are very similar to Homo sapiens. They're our closest relatives that we know of at a species level, but they're products of a shared evolutionary history, not creationism. Anyways, my gentle and of course very modern apes, I hope you enjoyed this one. I've been meaning to get this one out for a very, very long time, and a very special thanks to Dan of Creation Myths and Walker of Just a Walking Fish for giving me permission to use these clips, and also just for putting the information out there on the genetic stuff. Again, I'm a morphology gal. I'm a simple and modern non-geneticist, if you will, so I have to rely on the experts in those fields in order to make sure that you get all of the information you need for this type of argument. So I thank them very much for doing their legwork, for doing that legwork. If you like what I do, please consider liking, commenting, and subscribing. It helps the channel, and it's totally free. And if you want to support me in a more financial way, you can join my Patreon. Patrons get early access to videos when I'm on top of things, and they get their names at the end of the video. So from the bottom of my gentle and of course very modern heart, I would like to thank you for being a curious primate, and I'll see you really soon next time.